To you about waves and vibrations. And this one is a transversal wave, and we'll explain it through a pendulum for demonstration. Alright, so say you start it just hanging there. That would make it at 0, which would be the line on the wave. And when you bring it up to a certain angle, it would be at the crest or the highest point, which would be that or that over here. And then you go back down to 0, which would be the line again. Then it would go back up to the trough, which is the lowest point on the wavelength, or the wave, transversal wave. From top to top, that would be one wavelength, and the period would be it just going from the crest to the trough, because it would be a complete wave, like if it started from 0 and then went up back to 0. The amplitude, which is represented by the string, because that's how high up it will go, affects the loudness of what you're hearing. So if you have a shorter amplitude, it will go faster than if you had a longer amplitude, and that would raise the frequency also, because frequency is number of waves over the seconds it takes to complete them. So that just is demonstrated through the pendulum and how fast it takes to complete a wave. Now normally it would just continue forever, but air friction, air resistance causes it to eventually stop. But in a perfect world, it would continue from the same angle that you released it at. I made a very basic pendulum, a more complex one than the simple one you just saw, but the same principles apply to it. That has many simple pendulums attached to it, but each one has a shorter string. So when we set them all off at the same angle, due to what we were showing you before, that would imply they would fall at different rates, and let's see what happens. Yeah, so it makes like its own little wave pattern in itself. That one on the end is weird. Anyways, so yeah, Air Force stops it eventually. That's the pendulum. So this is a compressed wave, and the one we just learned about was transverse wave. Now, in comparison, this has mostly to do with sound, and the 0 in this would be the refracted waves, which is when the molecules and everything is all spread out, not brought together by the sound waves. And the crest and trough are kind of the same thing, but they interval between zeros. And that's like when all of the molecules and things are compressed by the sound or whatever the cause is. And if we come back to what frequency is, that is the number of waves divided by the seconds it took to complete those waves. Alright, so we'll time this, and then we'll show you the number of waves over the number of seconds. Alright. In order to get a higher frequency, they would be closer together or more compressed in the compressional waves, or shorter wavelengths in the transversal waves. And to raise the amplitude, you would have a greater magnitude between the crest and the 0 point, or the trough and the 0 point, midpoint, central point. That brings us to the Doppler effect, which is when you are farther away from something, the frequency will not be as high, so it won't be as loud. The amplitude won't be as high either, because it won't be as loud. So, as you saw, the farther he was away from me, the central point, I suppose, the quieter it was, the lower the amplitude and frequency, and then the closer he got to me, the louder it got, the higher the frequency, the higher the volume and pitch, and then he left, and then the reverse effect happened again. And back you go. I'm going to explain to you the physics of a car speaker. Okay, so in back you've got this, which would be attached to your stereo, which is what captures the frequencies from your radio station, the waves from the radio station, and then that goes into these, which are called isolated poles, which then send it into a coil, which is attracted by the magnet. That helps it get to it. The bigger the magnet, the more it gets to it. And then it sends it into the cone of the speaker, which vibrates, and it's rather large, so that also intensifies the sound. The bigger the magnet, the bigger the speaker, the bigger the sound and the number of waves that can be produced, so then you can get more bass. And that's why little speakers don't get very much bass, like your headphone speakers, unless they're large headphone speakers. And yeah, vibrations and waves, and it compresses in hours, and then that's how the sound is traveled and carried. Volume would be changed by changing the polarity between the magnet and the coils, like making it less or more intense depending if you want the volume louder or quieter, the amplitude lower or higher.